Hello, my name is Zack, and I'll be presenting FrameFix, automatically repairing statically detected directive violations in framework applications. This work was done at Carnegie Mellon University with my co-authors, Joshua Sunshine and Quayle Goues. Software frameworks are widely used in the software industry. Developers use frameworks to ease the development process. Instead of having to recreate an application from scratch for a specific domain, developers can use a framework for that domain, which gives them the common aspects of applications in that domain, and then they only have to create the unique parts of their application as a plugin. Shown here in the picture is an Android phone, which has multiple Android apps built on top of the Android framework. So before I go any further, I want to cover some definitions that I'll be using in this talk. The first is a module, which is a cohesive unit of code with an interface to use that code. The next is a framework, which is a set of modules that require clients to conform to a given software architecture. Then a plugin is a module that extends the framework to add specific functionality. Whenever a developer creates an application, they use the framework and a plugin together to make that full application. Developing with a framework is different from other forms of software development. In this case, I'll compare developing with a framework to developing a program that just calls out to a library. When you create a program using a library, your program controls the flow of execution and data. So you get to write the main function of the code and then call out to that third-party library whenever you need it to perform the provided functions. However, when you develop with a framework, the situation is different. The framework controls the flow of execution and data, since that process is general across applications in that domain, and instead you write a plugin that performs the unique parts of that framework application. And then the framework, when it determines it's the correct time to call your plugin, will call your code in your plugin, perform that execution, and then return the execution back to the framework. While developers are gaining a lot of benefits from using frameworks, they also encounter difficulties as well. One example that demonstrates this is the question topics on Stack Overflow. Shown here are the top 20 question topics on Stack Overflow about a year ago. And in this picture, 6 out of the top 20 categories are frameworks, which 1 shows that developers are commonly using frameworks, but 2, they're also encountering difficulties when using them. To further understand how developers are using frameworks and encountering difficulties, as well as try to come up with a way to address the problems that they're encountering, I earlier performed a separate study into the challenges that developers are facing. Now, some key takeaways from this study were that developers were having problems with certain unique aspects of the framework development process. The first one is inversion of control. Inversion of control is the situation where the framework controls the execution of internal framework code, but then calls out to the plugin at certain defined points and lets the developer do their unique code at that certain stage. In this case, you can see the framework calling out to the onCreate method and the onPause method at different times in the execution process. Another unique aspect of frameworks that developers were having challenges with was the heavy use of object protocols. Object protocols are the restrictions on calling object methods when objects are in certain states. An example of this is a plugin cannot change the theme of a view object once the plugin has set the view to be shown to the user. Essentially, this is saying that once the view object is in a shown to the user state, the set theme method cannot be called anymore on that object. Now, object protocols occur in other forms of software development, but It's different in frameworks for two reasons. One, frameworks heavily use object protocols. And two, frameworks will change the state of objects internally, and developers are not always aware of the state of the object that they're receiving. To further focus my investigation of plugin problems, I decided to focus on directives. Directives are a method specification that conveys an important yet often unexpected instruction to callers. Essentially what this is saying is an extra requirement on calling that method that's not enforced by the type system. So a high-level example is calling a method before the correct initialization steps can lead to an error in the application. To address the problem spaces discussed earlier, I created FrameFix, an automated repair technique for addressing directive violations in framework applications. FrameFix was designed to generalize to different languages and frameworks. However, the current implementation of FrameFix uses static analysis to identify directive violations and to determine when those directive violations were removed. This added some language overhead for implementing the tool, and so the current implementation of FrameFix was implemented for Java and the Android framework. The design of FrameFix repair technique was based on the two unique aspects of framework development that I discussed earlier. To fix object protocol issues, it performs a method move repair. And then to fix inversion of control issues, it performs a GitHub repair. And I'll elaborate on these repair techniques further. FrameFix was designed to be used in a two-step process. The first main step requires someone with knowledge of the framework to define the information required for the FrameFix repair process. This person knowledgeable of the framework, likely the framework developer, would specify the analysis check to perform to check if the application is conforming to directives, as well as defining any repair-specific variables needed in the repair process, such as keywords to look up whenever using the GitHub search. Then, once someone knowledgeable in the framework has defined that repair, which they only have to do one time, multiple plugin developers can then use that information encoded to check if their application conforms to that directive, and if not, FrameFix can try to generate possible solutions to fix that issue. The plugin developer would have an application with possible error. They'd then run the analysis check on the application. If FrameFix determines that it contains a problem, then FrameFix will generate possible repairs, and they'll run analysis checks to see if that problem was removed. If the error is still detected, it'll generate more repairs, and if the analysis check passes, then FrameFix will determine that it fixed the application. FrameFix is a technique in the generate and validate paradigm. Shown here is a high-level overview of that process. The repair technique, in this case FrameFix, takes in a buggy program as input. It then locates the fault inside the program and generates possible solutions for that fault. It'll then evaluate those possible solutions to determine if it needs to generate more, if it didn't fix the issue, or if it fixed the issue, producing a fixed program. If the generate and validate paradigm ever produces a fixed program, it'll eventually time out at some point. To determine where the problem that needs to be fixed, as well as to determine if possible solutions actually fix the issue, FrameFix uses static analysis. This static analysis was built using FlowDroid, which provides information on how state is changing inside methods and also provides call graph information. FrameFix will also use any provided test cases to evaluate possible solutions, ensuring that developer intended behavior is retained. And then to generate possible solutions, FrameFix uses two techniques. One, moving methods to other locations, and using code on GitHub as examples to generate a new section of code. Shown here is a more in-depth diagram of the FrameFix repair process. Steps in this process are ordered according to the worst case time it would take to perform that repair, with the shortest being at the beginning and the worst being at the end. The first step in this repair process is reordering method calls in a function. So FrameFix tries to reorder how the methods are occurring, hoping that the methods are just called in the wrong order. If that doesn't work, it will then try to move the problematic call to another method, in this case hoping that the objects in that method call will now be in the correct state. Finally, if that doesn't work, FrameFix will use GitHub repair. GitHub repair works by using a specific search query, which I'll show an example of later, to find reference applications. It will then use the method call name of the problematic section of code to identify the reference method call in that new application. If it doesn't find a fix with that current application, it'll then try code from the next application and continue on in that case. For a specific method of reference, it'll first look at the method differences by line to see if certain method calls are happening in the reference method call or happening in the problematic code where it shouldn't. If that doesn't fix it, it'll then look at type differences. To evaluate FrameFix, I looked into multiple questions. The first is, do the directives used in the evaluation apply to real applications? The second is, does the directive violation check process generalize to real applications? Third is, do the repair techniques generalize to multiple directives? And finally, do the repair techniques apply to real applications? Due to the time limitations of this presentation, I only have time to go into the second two bullets, so I'll point you to the paper for the other two. To determine if these repair techniques generalize to different directives, I created an evaluation set where I took 10 different directives from the Android documentation and a sample Android application that was provided on a sample page, and then manually added these directive violations to that sample application. I then ran FrameFix and found that FrameFix was able to fix 7 out of 10 different directives. You'll see the options menu directive listed twice because there's 2 different ways to violate it, and FrameFix was only able to fix one of them. Elaborating further on that options menu case, I want to give you an example of FrameFix repairing a problem in a real application. So the directive for this example is to use the fragments options menu. The application must contain both the call set has options menu true and define the onCreate options menu method. So shown here is an application sky view taken from F-Droid, an open source Android marketplace. This application defines the onCreate method and the onCreate options menu method, which defines how an options menu should be shown, but it doesn't actually call the code to show that options menu in the onCreate method. So FrameFix will then query GitHub running this specific code query to try to find similar application code to the problematic code shown here. The codes in blue are the developer-defined keywords that come directly from the directive. That GitHub search query will then find this reference application, what's that viewer page master, which contains the code shown on the right. It will then notice that the reference application contains a different method call, set has options menu. It will then move over that new method call and add it to the original problematic application, fixing the issue. Due to the difficulty of running these applications, I collected the applications that violated the directive and also contained test cases, and then injected these directive violations randomly into them. FrameFix was able to fix most of these cases, but it didn't work perfectly on the get activity case and the inflate case due to the problem of finding places where to move the get activity call, and also a combinatorial explosion for very long methods it was finding off of GitHub. In conclusion, framework application repair can be based off unique aspects of frameworks, and framework callbacks can be used to locate correct implementations of code off of GitHub. Thank you, and let me know if you have any questions.